Hello everyone, welcome back. So in this session, let's talk about integer data types. Okay, what are they and how do you represent them? Let's take a deeper look into integer data type. So when it comes to computer programming or representing data or storing data, all right, integer data types are those type of values, those types of whole numbers. They are whole numbers. Okay, we use integer data types to represent whole numbers. Numbers like 55, 79, 1007, all right? So they don't have any fractional or decimal parts. They are just whole numbers, okay? They don't have any decimal in them, okay? They are very fundamental in programming and computer science for storing numeric value where only whole numbers are valid, okay? Yeah, when you start programming, or if you have been programming already, there are places where you only need whole numbers. When you want to talk of somebody's age, you only store their age, whole number. You don't say this person is 25.9 years old. No, it is going to be a whole number. Okay, so this is where we use integer data types. Okay, so let's take a look at some of the key characteristics of integer data types. First of all, they are whole numbers only. They are whole number. They don't have any fractional part, don't have any decimal parts. Okay, there's no decimal part, there's no fractional parts. They have a range, and their range actually, we have different types of integers. We'll take a look at them later on in this session. So we have different types of integer, and these different types of integers are actually categorized based on the number of bits or the size of that integer. You know, remember that we use bits, zeros and ones. That is what computer understands. So if you want to store any value, all right, you actually use zeros and ones to store this value. And there is a way the computer has actually been created that these patterns of zeros and ones could mean different things. So, but right now we are talking about integers. So we could actually store an integer using 8 bits. We could store an integer using 16 bits. We can store an integer using either 32 or 64 bits. Yeah, so this depends. This actually determines the size. An integer of 16 bits is actually bigger than an integer of 8 bits. Do you understand? And apart from that, we also have something we call a signed integer or an unsigned integer. We are going to get into that later on, okay? So signed and unsigned integer, all right? Signed integers, they can represent both positive and negative values. You know, sometimes your integers, even your whole numbers, they can be negative, all right? You can have some negative values, all right? -5, -50, -100. You have to also represent these negative numbers. Do you understand? So when we say signed integers, it means that they have a sign in front of them, either minus or plus. But when it is plus, there is no need to, when it is a positive number, there is no need to add plus in front of it. But if it is a negative number, you actually preface it with minus sign. So it has a sign. So these integers, they have a sign. That's why we call them signed integers. So they can represent both negative numbers and positive numbers. We also have another type, another category that we call unsigned integer. All right. They represent non-negative numbers, 0 and positive numbers only. All right. They represent non-negative numbers. So we are going to talk more about this signed and unsigned integers in the next section, where we'll take time to explain it better. Okay. So let's take a look at common data types, integer data types, and their sizes in some programming languages. We have the int8. It is called byte. All right. Int8 means that it is this integer. We are using 8 bits to represent this integer. We are using 8 bits to represent the integer. All right. So it has another name called byte. Remember that 8 bit, all right, 8 bit makes up a byte. Do you understand? So this type of integer uses 8 bits to represent data, all right, and the signed, look at it, when you have a number of bits, all right, that number of bits can be used to represent 2 raised to power that number of bits. Okay, look at it. Let's say we have 8 bits, all right? With 8 bits, the computer can represent 2 raised to power 8 different values. 2 raised to power 8 is 256. That means the computer can represent 256 different values. All right, it can represent 256 different values using 8-bit. Now, when we talk of the signed integers, all right, the 256 values that can be represented using 8-bit, we divide it into two. Half of it will be used to represent negative numbers, and the other half will be used to represent positive numbers. That is why you see we have from -28 to 127. So the unsigned, since we are not representing negative numbers, we are using all the 256 values for positive numbers. So from 0 to 255, all right? So for int 8, it has 8 bits. It uses 8 bits to represent integers, and it has signed and unsigned types. Now, the signed one we divide the 256 values that can be represented using 8 bits. We divide it into two, -128 to 127. So the first part will be used to represent negative numbers. Second part will be used to represent positive numbers. But for the unsigned, since we are not concerned about negative numbers, we use all the 256 values to represent only positive values. All right. We also have the int 16, which is also has another name called short. Okay, so it uses 16 bits and it can represent 2 raised to power 16 different values. 2 raised to power 16 will give us 65,535. That 536. So the sign short or the sign in 16, we will use half of it to represent negative and use half of it to represent positive. While the unsigned, we'll use all of them to represent positive values. So the same thing applies to int 32, and it has an alias of int, all right? 8-bit, sorry, it is not 8-bit, it's 32-bit. Sorry, my bad. It's a mistake. It is 32-bit. It uses 32 bits. So with 32 bits, we can represent 2 raised to power 32 different values. And if you do that, if you do your mathematics well, 2 raised to power 32 is going to give you 4 billion, all these things. So these are the ranges. These are the ranges. For the signed value, we will use half of it to represent negative ones and use half of it to represent positive ones. We also have the int 64, which is the long. It uses 64 bits to represent integers. It is this big. All right. The range is massive. All right. So in case you're calculating the population of the whole world, all right, you can actually use long. Okay. So let's talk a bit about signed and unsigned integers. The signed integers, all right, they use 1 bit to represent the sign of that value. All right. Something we call the most significant bit. Out of the, let's consider 8 bits integer. Out of the 8 bits, 1 of the bits will be used to represent the sign, while the remaining 7 will now be used to represent values. Okay, let me show you. Let me go to my board. Okay. I want to just show you something and show you what we mean by the most significant bit and how we actually use the most significant bit to represent the positive, the sign of that number. Okay, this is taking time to load. All right, I will have to leave it. All right, don't worry. When we actually get down to, we will still talk about signed and unsigned integers later on. So, but for the unsigned integers, all the bits are used to represent the value, the magnitude of that number. So it doubles the maximum positive number they can hold compared to signed integers. Let me explain this. With signed integers, let's say we have 8 bits, signed integer. 1 of the bits will be used to represent the sign, whether positive or negative, while the remaining 7 bits will be used to represent the magnitude of the value. But for the unsigned, since we are not considering any negative or positive numbers, all the 8 bits will be used to represent that particular value. Okay, let me try and see if my board is up now. Okay, it's not up yet. So we'll continue. But we'll talk about this in the next. We'll talk about this in the next session. So for signed 8 bits, remember signed 8 bits can represent both positive and negative numbers. So out of the 8 bits, we'll use one of the bits to represent the sign. So whatever, if the sign is 0, if that bit is 0, that means it's a positive number. If the bit is 1, that means it's a negative number. Don't worry, you understand better in the next session, okay? So on signed 8 bits, we use all the 8 bits to represent the value, the magnitude of the value. All right? So integer representation in memory. When it comes to memory, of course, when you have an integer, you are actually storing it in memory. So how is integer represented in memory? First of all, everything in computer, both the memory, are represented in binary format, zeros and ones. So it's a pattern or a sequence of zeros and ones. So if you have an 8-bit integer, we are going to have 8 zeros and ones. Okay, so there's another type of integer representation we call the 2's complement. We'll talk more about this 2's complement in the next session. Okay, this is the most common way to represent signed integers in modern computers. All right, we'll talk about it. All right, so it allows for simple arithmetic and easy sign handling. All right, don't worry, in the next session we'll talk about, there are 4 representations of integers in memory or in computer. All right, we'll talk about them in the next session. Okay, so we also have something we call the overflow. We have overflow and underflow. We'll mention this thing more when we talk about arithmetic operation in integers. Okay, but let me explain a little bit. This occurs if a calculation produces a value outside the allowed range. Now, let's assume that you go to fetch water with a 5 liters gallon. If you go to fetch 5 liters, if you go with a 5 liters gallon, if you try to fetch 6 liters into that 5 liters gallon, that will be an overflow. That will be an overflow. So this thing will produce a value that is outside the allowed range. Every integer data type has an allowed range. Int 8 or byte has range of 256 for unsigned and minus 128 to 127. So if you ever give it any value that is beyond its range, there will be an overflow. All right. So there is more to come on that. All right, in the next few sessions coming. Okay, so with this overflow, many programming languages have different ways of handling them. All right, they could wrap it around, they could saturate it, or they could place error. Okay, so but don't worry, we'll talk about that in the next couple of sessions. So let's talk about integer data types in popular programming languages. So let's take a look at C. C, all right, has an integer data type called int, which is the 32-bit. All right, they also have short, which is 16-bit. They also have long, which is either 32 or 64, depending on the platform. And they also have long, which is at least 64-bit. All right. So, but don't worry, when you start learning these programming languages, you're going to see these things come to play. All right. So, all of these, both the int and the short and the long and the long, they all have both signed and unsigned variants of each of them. In Java has bytes. But you can see that C++ does not have byte. But Java has byte, all right? And it uses 8-bit. Now, let me explain a little bit here. I don't know if I'm going to confuse you, but let me just try not to confuse you. 8-bit, all right? Because Java has a data integer data type of 8-bit, it means that for C++, the list is 16-bit. But for Java, the list is 8-bit. Now look at it. If you try to store something like 1 or 2 or 7 or even 250, all right, it is enough to use 8 bits. So when you try to store 8 bits, let's say in Java now, when you try to store 8, you want to store something like 250, Java will see it as, oh, okay, I can actually use, and you indicate the data type as byte. Java is going to use only 8 bits to store that value. But for C++, since the list is 16-bit, if you try to store something like 250, of which 8-bit is enough to store it, but C++ does not have it, C++ is going to use 16-bit to store that 8-bit value. You can see now there is excess of bits being used. So Java Java byte is more efficient when it comes to memory management. So these are the reasons why you need to understand these things. That is the reason why we are teaching you these things. When it comes to computer programming, now I can explain this and I understand this thing because I understand this bit representation and all those things. So representing 250 with 8-bit is more efficient than representing 250 with 16-bit. 16-bit is too much. There is no need. We are wasting memory. Okay. We also have the short in Java, 16-bit. We have int32, all right, and we have long, 64-bit. In Java does not have unsigned primitive integers. All of them are all signed. Do you understand? Okay. So in Python, Python is a dynamic language. All right. It doesn't have any fixed size. It doesn't have anything called data type that you come and say when you're declaring your variable, you give it a data type. Python grows arbitrarily large. So you can store anything. All right. So that is for Python. So they don't have anything like byte, int, short or long. They don't have anything like that. Even JavaScript, everything in JavaScript, all numbers in JavaScript are floating point numbers, except for the big int. So JavaScript does not have anything like bytes, int 16, int 32. No, it doesn't. All right. We only have one integer data type in JavaScript, and it is called number. And it covers both floating decimal numbers and whole number. Okay, so integer limits and safe usage. Integer overflow. Whenever you try to every integer have their maximum and their minimum value. So you don't overflow. All right. If you have an 8-bit integer, all right, which is something like the byte in Java, you cannot give it something that it cannot handle. 8-bit or bytes in Java can only take from minus 128 to 127. Remember, Java does not have signed or unsigned variant. These are the reasons why you need to understand all these things. So since Java does not have unsigned variant, that means all of them are all signed. So the byte, which is 8-bit, will take between 128 to 127. So if you try to give byte 128, it will not take it. It will be an overflow. Because if you look at the range, byte says I can only take between minus 128 to 127. And you're trying to give it 128, which is outside or beyond its range. It will not take it. Okay? Now, some languages like Rust or Swift, they can actually throw some errors, all right, when there is an overflow. Okay, so use larger types if possible to avoid overflow. So when you actually know the value or the magnitude of the integer you want to use, you actually use the appropriate data type, the appropriate integer data type for it to avoid overflow. Okay, so thank you very much. In the next session, we'll talk more about signed and unsigned integers, and we'll also talk about the representations of integers. See you in the next class.